Hello children, let us understand circular motion. Consider a particle is moving along this curve in 2D Cartesian coordinate plane. At some point of time, it is at point P. Its position can be represented by polar coordinates r, theta, where r is magnitude of vector OP and theta is the angle that vector OP makes with positive x-axis. At some other point of time, we can represent particle's position by these polar coordinates r, theta. Let us consider three cases. Case 1. If only r varies, theta is constant. That means particle will travel in a straight line. Case number 2. If only theta varies and r is constant. That means particle will travel on a circular path. Case number 3. If both r and theta vary, that means particle will neither travel on a straight line nor on a circle. It will travel on some other curve. Let us see angular variables. There are three angular variables we will talk about: angular position, angular velocity, and angular acceleration. Angular position is represented by theta. Its unit is radian. Angular velocity is represented by omega. Its unit is radian per second. Angular acceleration is represented by alpha. Its unit is radian per second square. They are analogous to position, velocity, and acceleration, that is x, v, and a in rectilinear motion. Consider a particle is moving on this circular path. It has center at O, OX is x-axis. At t is equal to 0, particle was at point P. At t is equal to t, particle was at point Q. And at t is equal to t plus delta t, particle was at point R. At point Q, angular position of the particle is theta. At point R, angular position of the particle is theta plus delta theta, where delta theta is angular displacement of the particle. Its angular velocity omega is rate of change of angular position, which is given by delta theta upon delta t, where limit delta t tends to 0, and that is d theta upon dt. Similarly, angular acceleration is rate of change of angular velocity, and that is d omega by dt, and that is equal to d square theta upon dt square. Let us see what happens when omega is constant and when alpha is constant. Suppose omega is constant. That means d theta upon dt is constant. D theta upon dt is equal to omega, or d theta is equal to omega dt. Let us integrate both sides of this equation within limits. D theta within the limits theta 0 to theta and dt within the limits 0 to t. So integration of d theta from theta 0 to theta will be theta minus theta 0. Since omega is constant, so it can be taken out. So it will be omega into integration of dt from 0 to t, and that will be omega t. So it will be theta is equal to theta 0 plus omega t. We can use this equation when omega is constant. If alpha is constant, that means d omega by dt is constant. D omega by dt is equal to alpha, or d omega is equal to alpha dt. Integrate both sides of the equation within limits. D omega from omega 0 to omega and dt from 0 to t. So left hand side will be omega minus omega 0. Since alpha is constant, so it can be taken out. So right hand side will be alpha into integration of dt from 0 to t, and that will be alpha t. So omega minus omega 0 is equal to alpha t, or omega is equal to omega 0 plus alpha t. Similarly, we can find these two equations. Theta is equal to theta 0 plus omega 0 t plus half alpha t square, and omega square is equal to omega 0 square plus 2 alpha into theta minus theta 0. These three equations are analogous to motion in a straight line. First equation is analogous to v is equal to v0 plus at. Second equation is analogous to x is equal to x0 plus v0 t plus half at square. And third equation is analogous to v square is equal to v0 square plus 2a into x minus x0. Let us see proof of these two equations. Proof of this equation first. Angular displacement delta theta is equal to omega average into delta t. Delta theta is theta minus theta 0 and delta t is t minus 0. Omega average is omega 0 plus omega upon 2. Put the value of omega from first equation. Omega is equal to omega 0 plus alpha t. So it will be theta minus theta 0 is equal to omega 0 plus alpha t upon 2 into t. On simplification, it will give theta is equal to theta 0 plus omega 0 t plus half alpha t square. Now let us see proof of third equation. First equation is omega is equal to omega 0 plus alpha t. Square both sides of the equation. So we get omega square is equal to omega 0 square plus alpha square t square plus 2 omega 0 alpha t. Take 2 alpha common in these two terms. So we get 2 alpha into inside the bracket 1 by 2 alpha t square plus omega 0 t. Rearrange the terms, we get omega 0 t plus 1 by 2 alpha t square. Value of omega 0 t plus alpha t square can be put from second equation, and that is equal to theta minus theta 0. So we have got omega square is equal to omega 0 square plus 2 alpha into theta minus theta 0, and that is third equation of circular motion. Suppose the particle travels a small distance delta s on circular path in time interval delta t. Its angular displacement is delta theta. Then from trigonometry we can say that delta s is equal to r into delta theta. If we differentiate both sides of this equation with respect to time, we get delta s upon delta t is equal to r into delta theta upon delta t. Delta s upon delta t is represented by v, which is linear speed of the particle, not linear velocity. Delta theta upon delta t is omega. So we have got this formula, v is equal to r omega. Now, if we differentiate both sides of this equation with respect to time again, we get dv by dt is equal to r into d omega by dt. dv by dt is represented by at, which is tangential acceleration of the particle. d omega by dt is alpha. So we have got another formula, at is equal to r alpha. Let us find out two components of acceleration in circular motion. Suppose a particle is moving on this circular path. At some point of time, it is at point P. Position of this point can be represented by polar coordinates r, theta. Magnitude of vector OP is r, which is radius of the circle. Angular position of point P is theta. Extend OP till A so that PA is a unit vector represented by vector ER. Draw a tangent at point P and extend till P so that PB is another unit vector represented by vector ET. Now we will write vector ER and vector ET. Vector ER is equal to vector PA. It can be written as PA cos theta I plus PA sin theta J. Magnitude of PA is 1. So vector ER is equal to cos theta I plus sin theta J. Similarly, we can write vector ET. Vector ET is equal to vector PB. This angle is 90 minus theta. So we can write vector PB as PB cos 90 minus theta into minus I plus PB sin 90 minus theta into J. So vector ET is equal to minus sin theta I plus cos theta J. Magnitude of PB is 1 as it is a unit vector. Vector r is equal to vector OP. It can be written as r cos theta I plus r sin theta j. If we differentiate both sides of this equation with respect to time, we get velocity of the particle at point P. So velocity v is equal to dr by dt, and that is equal to d by dt of r cos theta I plus r sin theta j. When we differentiate first term with respect to time, we get minus sin theta d theta by dt I. When we differentiate second term with respect to time, we get cos theta d theta by dt j. d theta by dt is omega. So we can take omega common in both the terms and can be taken out. So vector v is equal to r omega into minus sin theta I plus cos theta j. In place of minus sin theta I plus cos theta j, we can write vector et. So vector v is equal to r omega into vector et. Vector et is unit vector. What this means is magnitude of velocity at any point p is equal to r omega, and direction of velocity is along the unit vector et, which is tangent at that point p. If we differentiate both sides of this equation with respect to time, we will get acceleration of the particle at point p. So acceleration A is equal to dv by dt, and that is equal to r into d by dt of omega into minus sine theta I plus cos theta j. We will get d by dt of omega into minus sine theta I plus cos theta j by applying chain rule. So it will be omega into d by dt of minus sine theta I plus cos theta j plus minus sine theta I plus cos theta j into d omega by dt. Now we can split this into two terms. First term will be r into omega into d by dt of minus sine theta I plus cos theta j will give minus cos theta d theta by dt I minus sine theta d theta by dt j. Second term will be r into d omega by dt into minus sine theta I plus cos theta j. In place of minus sine theta I plus cos theta j, we can write vector et. So second term will be r into d omega by dt into vector et. We will simplify first term now. Since both the terms are negative, so negative sign can be taken out. So first term will be minus r omega into. In place of d theta by dt, we can write omega. So inside the bracket will be cos theta into omega I plus sin theta into omega j. Omega can be taken common in both the terms, so it can be taken out. So first term will be minus r omega square into cos theta I plus sin theta j. In place of cos theta I plus sin theta j, we can write vector er. So first term will be minus r omega square into vector er. Now we will simplify second term. Second term is r d omega by dt into vector et. Since r is constant, so it can be taken in. So r d omega by dt can be written as d by dt of r omega. We know that r omega is v. So put v in place of r omega. So second term will be dv by dt into vector et. So acceleration of the particle can be written as minus r omega square into vector er plus dv by dt into vector et. First term is called as radial acceleration. It is represented by ar. And second term is called as tangential acceleration. It is represented by at. Negative sign suggests that it is opposite to unit vector er. Unit vector er is radially outwards. So radial acceleration ar will be inwards towards the center. Magnitude of radial acceleration is r omega square. Put omega is equal to v by r. So magnitude of radial acceleration is v square by r. At is equal to dv by dt. You need to remember these two formulas. There are two components of acceleration of the particle. They are radial acceleration and tangential acceleration. If the speed of the particle v is constant, that means dv by dt is equal to 0. Put dv by dt is equal to 0 in this equation. So particle will have only radial acceleration component, no tangential acceleration. Magnitude of radial acceleration is v square by r. Motion of the particle in this case is called as uniform circular motion. Since particle is having only radial acceleration component, so it will experience a resultant force acting towards the center. This force is called as centripetal force. Magnitude of centripetal force is mv square by r. If particle is having non-uniform circular motion, it will have two non-zero components of acceleration. One is radial acceleration, another is tangential acceleration. Magnitude of resultant acceleration is equal to under root v square by r whole square plus dv by dt whole square. Now let us solve few questions based on what we have learned so far in circular motion. First question, a particle moves in a circle of radius 20 cm at a speed that uniformly increases. If the speed changes from 5 meter per second to 6 meter per second in 2 seconds, find the angular acceleration. From the given information, we can calculate tangential acceleration at. At is equal to change in speed upon duration. So that will be equal to 6 minus 5 upon 2, and that is 1 by 2 meter per second square. Radial or angular acceleration alpha is calculated by the formula alpha is equal to at upon r. At we have calculated as 1 by 2 meter per second square. R is the radius of the circle. It is given as 20 centimeter or 0.2 meter. So alpha is equal to 1 by 2 upon 0.2, and that is 2.5 radian per second square. Second question, a particle moves on a circular path of radius 4 meter. Distance traveled by the particle in time t is given by the equation s is equal to 1 by 3 t cube. Find its speed when tangential and radial accelerations have equal magnitude. We can calculate speed of the particle v by the formula v is equal to ds by dt. It is given that s is equal to 1 by 3 t cube. So ds by dt will give 1 by 3 into 3t square, and that is t square. So speed v is equal to t square. This is equation number 1. We can calculate tangential acceleration at by the formula at is equal to dv by dt. v is equal to t square. So dv by dt will give 2t. That means at is equal to 2t. This is equation number 2. Radial acceleration ar or alpha is equal to v square by r. v is equal to t square. So ar is equal to t to power 4 upon r. This is equation number 3. It is given that magnitude of tangential acceleration and radial accelerations are same. That means 2t is equal to t to power 4 upon 4, or t into 8 minus t cube is equal to 0. That gives either t is equal to 0 or t is equal to 2 seconds. T is equal to 0 means at start v is equal to 0. Speed of the particle is 0. So we will not take t is equal to 0. We will consider only t is equal to 2 seconds. So speed of the particle v is equal to t square. Put t is equal to 2. So v is equal to 4 meter per second. Third question, a particle is moving on a circular path with a constant tangential acceleration. After 2 seconds from the beginning of motion, angle between the total acceleration vector and the radius r becomes 45 degree. What is the angular acceleration of the particle? Suppose the particle is moving on this circular path. OX represents x-axis, O is the center of the circular path. At t is equal to 0 second, particle was at point P, and at t is equal to 2 seconds, particle was at point Q. It is given that at Q, resultant of tangential and radial acceleration vectors makes an angle 45 degree with radius OQ. We know that tangential and radial acceleration vectors make an angle 90 degree with each other. So if their resultant makes an angle 45 degree with radial acceleration vector, that means at Q, magnitude of tangential acceleration and radial acceleration is same. So we can say mod AT is equal to mod AR at point Q. AT is given by dv by dt and AR is given by v square by r, where v is speed of the particle. Put v is equal to r omega. Since r is constant, so it can be taken out. So it will be r into d omega by dt is equal to v square by r. D omega by dt is equal to angular acceleration alpha, which we have to calculate. So r alpha is equal to v square by r, or alpha is equal to v square by r square. Again put v is equal to r omega. So we get alpha is equal to omega square. Suppose this is equation number 1. Since angular acceleration alpha is uniform or constant, we can use this equation omega is equal to omega 0 plus alpha t. Omega 0 is 0 because at t is equal to 0, particle was at rest. So omega is equal to alpha t. Put t is equal to 2 seconds. So we get omega is equal to 2 alpha. Suppose this is equation number 2. Put the value of omega in equation number 1. So we get alpha is equal to 0.25 radian per second square. Fourth question, a small block of mass 100 gram moves with uniform speed in a horizontal circular groove with vertical side walls of radius 25 cm. If the block takes 2 seconds to complete one round, find the normal contact force by the side wall of the groove. Suppose this is horizontal groove in which a small block of mass m is rotating on a circular path. So when it is rotating, it will experience a centripetal force which is directed towards the center, and that will be equal to normal reaction applied by the wall. So we have to calculate normal reaction applied by the wall, which will be equal to centripetal force, and it is given by mv square by r, where m is the mass of the block, r is radius of the circular path, and v is speed of the block. So speed of the block can be calculated by 2 pi r by t. It is given that it takes 2 seconds to complete one round. So v is equal to 2 pi into r is given as 25 centimeter, that is 0.25 meter, and time is 2 seconds. So v is equal to 0.25 pi meter per second. So normal contact force N is equal to mv square by r. M is 100 gram or 0.1 kg. So it will be 0.1 into v square, that is 0.25 pi square upon r. R is 0.25 meter. So N is equal to 0.25 Newton. In the next video, we will see circular turnings and banking of the rods along with centrifugal force. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.